Hi everyone, this is Mrs. Pagan, and in today's lesson we'll be talking about solving linear systems by substitution. Alright, so far we have learned one other method, so let's talk about the methods of systems, of solving systems. And so far the only one you know is graphing. By the end of today you will know substitution. And basically these are the two methods that we have so far. We will show more methods along this unit, but that's going to be your two favorite ones so far. Alright, let's talk about solving a linear system by substitution. So first is we solve for one variable. So it could be x or it could be y in one of the equations, and we substitute the expression, whatever that is, from step 1, which is this one, into the other equation. And a lot of people accidentally put it into the same one, and that's when errors kind of arise. So we want to make sure we use both of them. And then once we substitute the value from step 2 into the other one, the first one, then we get an answer that we're looking for, which we'll represent. So let's kind of show, I want to show you this in a problem, okay? So first of all, here's our example number 1. It says solve the linear system. And what you'll see is we have one equation here and another equation here, and those two create our linear system. And what we're going to do is we're going to pick one of the equations and we're going to solve for a variable. So I'm going to go ahead and pick equation 1, which is negative x plus y equals 1. And I'm going to get y by itself. So I'll do that by adding x to both sides. So this cancels and we're left with y equals x plus 1. Alright, so now that we've taken the first equation and solved it for the variable y, we're going to go ahead and input into the second equation. So here's our second equation, 2x plus, and instead of y, we're going to replace y with x plus 1 equals negative 2. So basically we took this and we replaced it with x plus 1. Alright. Then we solve for x because that's the only variable we have in there, and yes, we did that on purpose. So we have 2x plus x plus 1 equals negative 2. 2x plus 1x is 3x plus 1 equals negative 2. Subtract the 1, and we get 3x equals negative 3, and divide by 3, and x equals negative 1. Now, that's awesome because now we know what x equals, but what we want to know is what does x and y equals. So we're going to go ahead and substitute this into the next one. So we're going to go back to the first equation. I'm going to change my color. So we're going to go back to the first one. And we know that y equals x plus 1. And we're going to put in y equals negative 1 because that's what x is equal to here. Plus 1, which equals 0. So now we know that x equals negative 1 and y equals 0. But we're not done because we do have to write this as a solution. And the solution is a point. It's at negative 1 for the x, comma 0 for the y, and that's our final is the solution. That's the final answer. Alright, okay, so that's how the substitution goes, and we're going to practice this a couple times. But before we do, I think it's important you know, how do you know if a variable is easy to solve for? You don't want to make your life difficult, so what we do is we circle things that we know are easy to solve for. For example, I would solve and get x by itself in this case because x is pretty much already by itself. Whereas y has a 3 and it's like I don't want to deal with that, or 2 or negative 5. So x in that case would be the perfect choice. Now let's look at the second one. I would definitely get m by itself because it's already almost by itself. And that's the best part about it. Alright, why don't you try number 3? Which one would you get by itself? Drum roll, please. Alright, this was a tricky one. You get two answers. It could be x or it could be y. So either one of those would be fine, and in that case, it would be up to you. Alright, I love choices. Let's go into example 2. We're going to go ahead and solve for example number 2, and we're going to take those 3 steps. I like to label mine, so I'm going to say this will be my first equation, and The bottom one will be my second one. Now, what's so nice about this is step 1 is already done for us. X is already by itself. That's awesome. But a lot of people are like, why would you be so nice, and start questioning that. But yeah, they were really nice. So we already know that X equals 27, or 2Y, I'm sorry. So that's perfect. Now we're going to go into the second one, and we're going to substitute that in. 2 times, instead of X, we're going to write 2Y plus 6Y equals 15. 2 times 2 is 4Y plus 6Y equals 15. We have 10Y equals 15. Divide by 10. And Y equals, I think that simplifies to 3 over 2. Now, a lot of people at this point go, I did it wrong. It's got to be wrong. It's got to be wrong. And it's, no, don't be silly. It's okay. All right? So don't worry about it. You didn't do it wrong. We did actually a great job. And then what we're going to do is go back to the first equation, and we're going to substitute this in. We have X equals 2 times 3 over 2. And we have X equals, this is the same thing as over 1. 2 times 3 is 6. 1 times 2 is 2. And that simplifies to 3. Now, a lot of people get so excited. Yes, we're done. We're done. Not yet. Not yet. We're almost there. We're going to have to write it as a point. And the point will be 3 comma 3 over 2. Final answer. All right, well done. Let's look at example number 3. We're going to do this last one together, and then I'll let you go. You can try example 4 on your own. But let's look at this one. This one is a little bit different. You know, I can either solve for X or negative Y. I'm going to go with negative X. So I'll take the first one. Negative X minus Y equals negative 2. And I'm going to get X by itself. So I'm going to add the Y to the other side. We get negative X equals Y minus 2. Divide by negative 1 on each term. And X equals negative Y plus 2. So we got the first part. Now we're going to take this first equation that we transformed and put it into the second equation. So here's the second equation. It's 4 times, instead of X, we're going to write negative Y plus 2 plus 4Y equals 8. So distribute, and now we're getting into solving mode. We have negative 4Y plus 8 plus 4Y equals 8. Okay, now if we do know a couple things. We know that negative 4Y and positive 4Y is 0. So we technically don't have to write anything. And we're left with 8 equals 8. And that's just odd because now we don't have any variables to solve for. We're kind of stuck. We're done. Well, what's so cool about this is infinitely many solutions. And graphically, what that means is they're the same line. So if that was my y-axis and that was my x-axis, if I were to graph it, basically what it would look like is a line on top of the same line. So therefore, infinitely many solutions. Every point is a solution. It's pretty cool. All right. I want you to go ahead and try example number 4. And we're going to talk about this in class first and foremost before we start any of our group activities. Great job today. Keep it going, and we will see you in class.